So now we are going to start with thermal expansion in liquids. As we know, each and every state of matter, either it is solid, liquid or gas, there is always a thermal expansion whenever we are giving the heat to either solid, liquid or the gas. For the liquid also expand on heating, okay? But in liquids, molecules are loosely packed. As compared to solid, molecules of the liquid are loosely packed, so therefore they expand more as compared to solid. As in solid, particles are very close to each other and they need very much energy in order to lose their intermolecular force of attraction. But in the liquids, particles are already having less intermolecular force of attraction, so by gaining less energy only, they are just moving or they are just showing more thermal expansion, okay? But as we know, liquid are having the definite volume, but liquid are not having the definite shape, means we can easily change the shape of the liquid. Thus, by having only its definite volume, liquids can only show volume expansion because they are not having the definite shape. If they are not having its proper length, proper breadth, they are not going to show any linear expansion, they are not going to show any area expansion, they are just going to show its volume expansion because they are just having their definite volume, no definite shape is there. So now we are having next topic, that different liquids expand differently. As different solids are expanding differently, in the same way different liquids also expand differently. For example, in this beaker, I am having 3 different liquids, and whenever I am going to heat the liquids, same amount of heat I am going to give the 3 all liquids, these liquids also expand differently. For equal rise in temperature, different liquids were going to expand differently. For example, in the first beaker I am having ether, in second beaker I am having alcohol, and in third beaker I am having water, okay? So in different beakers I am having different liquids, but by giving the same amount of temperature, ether will expand more as compared to alcohol, and least there is an expansion in the water, okay? Next topic we are having anomalous expansion of water. Only little bit topic we are having in the 8th standard of the anomalous expansion in water. Proper study you will do in the higher classes. So what do you mean by anomalous expansion in water? See carefully. Actually, water show anomalous expansion. Means whenever water is heated from 0 to 4 degrees Celsius, in that case water contracts. Means from or in between 0 to 4 degrees Celsius, its volume contracts. But whenever we are giving heat beyond 4 degrees Celsius, then its volume going to start expanding. Then it is going to show the expansion. So by the given mass, the minimum temperature whatever we have to give in order to show the thermal expansion by water, that minimum temperature is 4 degrees Celsius, and this theory is known as anomalous expansion of water. So this thermal expansion of liquid is also going to depend upon 3 factors. And what are that 3 factors? See carefully. Firstly, it is original volume of liquid. Then we are having rise in temperature. And third, we are having the nature of the liquid used. So as we have already discussed that volume is only having its definite volume, but it's not having any definite shape. That is why in this liquid expansion, we will just discuss about the coefficient of the volume expansion. As we already know that, for example, here we are having beaker, and in this beaker water is there. Firstly, the volume of the water is V, but whenever I am giving the heat or temperature to this water, there is a change in the volume. So now this change will be delta V, okay? So here it will be delta T temperature. So this change in volume is going to depend upon 2 things, that is firstly original volume of the liquid, then we are having change in the temperature. But instead of directly proportional, we have to use the is equal to sign. So same delta V is as such is equals to, in volume expansion, same we are going to use the gamma, then V delta T. When we are having linear, alpha, for the superficial, beta, and for the volume, either it is for the solid, either it is for the liquid or for the gaseous, we are going to use the same coefficient, that is gamma, and then we are having V delta T as such, okay? Then we are having delta V over V delta T is equals to gamma, means coefficient of volume expansion means change in volume per degree original volume per degree rise in temperature. Means coefficient of the volume expansion is change in volume per unit original volume per degree rise in temperature. And similarly, we are having its SI unit also. Its SI unit is per Kelvin, or you can say per degree Celsius other unit, okay? So now we are having thermal expansion in gases. As we know, solids are having very tightly packed arrangement of the molecules. So there is a least expansion in the solids as compared to liquids. Liquids are having this much space that they are expanding properly. But gaseous are having very much spaces or very least force of attraction between the particles. So they are showing the very much thermal expansion. Instead of solid and liquid, we are having the very vast or large expansion, thermal expansion is there in the gaseous state. So by giving the same temperature to all states of matter, gaseous will show more expansion as compared to solids and liquids.